Welcome back. What I'm going to do in this video is to configure BGP. BGP is going to be a scalability mechanism in this case. And of course, BGP is going to have some more roles. But for now, I'm trying to make sure that even if I have thousands and thousands of MAC addresses or even more than that, I'm going to be able to handle this in my network. And I want to make sure that the reachability is there. I have not a lot of broadcasts in my network and stuff like this. All of them are going to be done with BGP. But specifically in this case, because we are troubleshooting, I'm just going to make some mistakes to see what the reasons of these mistakes, what the effects of these mistakes are going to be. Okay, so let's do this. The first thing you should know is right now I am saving everything in my data plane. After some time, this is going to age out. So on L1, for example, if I say show MAC address table and hit enter, you can see that some of the prefixes that I have learned are these. These are the MAC addresses actually, and I do not really have a lot of information about the IP addresses in here. So this is one of the limitations that we have in this. But the other thing is this is going to age out after some time if we do not really have traffic. And then anytime that we want to initiate the traffic, we have to go with an ARP, which is a broadcast, and it's going to contaminate our network if they are a lot. So let's just go with BGP. BGP is going to help a lot. So I'm just going to enable feature BGP on all of these devices. I'm just going to make sure that all of them are in the same autonomous system number. And then also the relative communities are enabled. So send communities enabled for them. Their relative address family is enabled for them. In my case, I do not really need to have IPv4. And you know that in Nexus switches, IPv4 is not enabled by default. That's a good thing. And on regular iOS, as a matter of fact, IPv4 is by default enabled. The rest of the address families are not. But in this case, we don't have any address family enabled by default. So what I'm going to do is to go and enable feature BGP. So let's just go to S1. And I'm going to say feature BGP and hit enter. The first thing that I'm going to do is I just want to enable console login. So I'm just going to say login console. So let's go with 5, which is going to give me some hints about the things that are happening for our adjacency. And then I'm going to say feature BGP. So feature BGP is going to be enabled in here. Then I'm going to say rather BGP 65001. Okay, so the first thing that I'm going to do is to make sure that I am using a loopback interface which is not used for NVE. Now, like I said, in production environments, on real gear, this might not be a very troublesome thing. But in reality, as a matter of fact, I have done this on real gear and on a virtualization environment all the time. I have used different loopback interfaces, and I have never encountered a problem. But in virtualization, at least I have seen that when you use the same loopback interface, that's going to cause some problem. And because sometimes virtualization is a reflection of the real world devices, I prefer to not do it on real gear, as a matter of fact, in production environments. So I'm going to go with loopback 0 in here. Loopback 1 has been used for NV and so other purposes in here, for example, for RP. So I'm just going to go with neighbor, and the neighbors are going to be like this, exactly like the topology that we have. Spines are going to be neighbors with leaves. They are not going to be neighbors with spines. Leaves are going to be neighbors with the spines. They are not going to be neighbors with leaves. So my neighbor is going to be 10, 10, 10, 3, 10, 10, 10, 3, which is in remote AS 65001. Let me see, show run interface loopback 0. So that's 10, 10, 10. That's okay. Okay, so this is this. And the address family which I'm going to enable is going to be L2 VPN EVPN. And for now, I'm not enabling some of the features that I have to enable. I just want to see what's going to happen in case I make these mistakes. So it's, deliberately, we are making some mistakes just to see what the problem is going to cause for us. And the other one is going to be 10, 10, 10, 4. So 10.10.10.4 is going to be this, and address family is going to be L2VPN EVPN. And if I say show run BGP, this is the configuration that we have. Now S1 and S2 are going to have the same configuration because both of them are neighbors with the same leaves. So I can just simply copy this and paste it in here. So I need to say feature BGP first to enable the feature, and after that I'm pasting this configuration in here, and that's it. So for now, nothing has happened. Okay, so we have just created this, and if I just exit this and exit this, and I have something like log neighbor changes. Okay, this is a good thing, and I want to do the same thing on here, log neighbor changes. I just want to see what is happening during the neighbor adjacencies. So let's go to L1 and L2. The same thing here. L1 and L2 are going to have almost the same configuration because both of them are connected to S1 and S2. So let's just go to configuration. I'm just going to say feature BGP, and feature BGP is going to be enabled. Rather BGP, let's say 65,001, and then I'm going to make some deliberate mistakes. So neighbor 10.10.10.1 is in remote AS 65,002, although it is SPY 1, but I'm just making a mistake in here. And address family is going to be L2VPN EVPN. Okay, so the other one is going to be in the correct place. It's a 65,000. So address family L2VPN EVPN, and log adjacency changes is going to be this show run BGP, and I have this configuration. Now what I'm going to do is to copy this and paste it to the other side, but this first part I just want to correct it on the other side. So let's just go to L2 and say feature BGP, then rather BGP 65,001, and then I'm going to have log adjacency changes, and my neighbor is going to be 10.10.10.1 in remote AS 65,001, address family L2VPN EVPN, and the other one is going to be 2. So in here we don't have so many mistakes, just a few that we have not added. And what we have here is, you can see that the first neighbor has been created, I guess. Yes, neighbor is up. The 4, which is L2, is up, and right now we are waiting for others to just see the messages in here. Okay, so others, of course, I just forgot to say login console, but on S1 I did. That's okay. Great. Now that I have done the configuration, let me see some verification commands. And I'm going to say show BGP. What is the address family? L2VPN. What is sub-address family? EVPN. And I'm trying to see the summary. So you can see that the first one, neighbor, is idle. I have not correctly configured that. Here, of course, I have set 65,001, 65,001. In here, if I just go to L2 and say show BGP L2VPN EVPN summary, actually, so you can see that this says that this is 65,002. This is in idle mode, and the BGP has not created the adjacency. Let's just do some debug, actually. So I'm just going to say debug BGP all, and hit enter. I'm just going to wait for some of the messages to see what the problem can be, and make sure that you do not really do debugging on your production environment. Debug can create a lot of messages, specifically if you go with all the types of debugging here, and that could lock you out of your system. This is one of the problems. And the other thing is this is going to be a huge burden on CPU. So you do not really want to do that. So I'm just going to say undebug all and hit enter, and debug is going to be finished. So let's see what the problem can be. I can just see the debug messages. Most likely what you're going to do is to capture this interface. That's going to be much better than going with debug, actually. So you can see that here it says that single BGP eBGP peer is not directly attached outward interface is unknown, so we don't really know about this. And somewhere here it should say that the BGP peer is configured in the wrong BG autonomous system. So you can just check this and figure out the problem here. So here it says that, for example, BGP this default skip resolving address, and then after that peer connection retry expired, and then the same message that we had there, starting timer like this, and then connection request, and after that we don't have resolution because we just skipped it. And all of these, of course, is going to hint us that there is some problem with the configuration in here. So what I'm going to do is to say show run BGP, and then this is going to be like that. I'm going to go to here and say this is the correct remote AS. So after some time, you should see that we are going to generate an adjacency with S1, and this is what we have. And then the message is going to be seen in here. Now that we have just created this, okay, so let's go for the rest of the configuration for EVPN, and this is going to happen in the leaves actually. So spines are not going to have a lot of configuration. All the intelligence is going to go into leaves in here. Let's go to here. The first thing that I'm going to see is whether I have enabled NV overlay EVPN or not. So if I say show run include EVPN, you can see that show run actually. Come on. Show run include EVPN. You can see that I have just made sure that NV overlay EVPN has been configured on L1 and L2. Of course, I have done it before, but this is important for us to know that this is configured for us. Okay, so after doing this, now what I'm going to do is to just add a line of command in here. What NV is what VNIs actually have we configured before. If I say show run VLAN, we can see that there is this VNI that I have configured for VLAN 10. So I don't really have a lot of VLANs configured in my case in here, and that's okay, no problem. So I'm just going to add a section in here. Normally you would think that this section goes under BGP, but as a matter of fact, this is an extra section that we have to configure, and that is EVPN. So under EVPN section, I need to go through each one of these VNIs and say whether this is going to be L2 or not. And after that, I'm just going to send some of the let's say specific characteristics to the other side. So I'm just going to say VNI is going to be this one, and we only have L2, so I have to go with L2 in this case. And then I'm going to say route distinguisher is going to be generated for me. I can generate route distinguisher myself, or I can go with auto. Better is going to be go with auto, and the reason for that is it's going to generate it based on the VNI number, autonomous system number, and that's going to be generated automatically for me. I don't really care about what is being generated for me, but if I try to do this specifically in a large environment, I may make a lot of mistakes. So this is easier for me. So you can see it says that unable to generate auto RD, no VLAN ID configured, and that's okay. This is just a cosmetic bug that we have. I'm just going to type it again, and after that I'm just going to type something route target. I'm going to have for both again created automatically. So I hit enter, route target is going to be created for me automatically as well. Okay, now the last section is going to be here. So interface NVE1 is going to have an extra line of command, and that's host reachability protocol. And you can see that for now, BGP is going to be the most important one, and we are going to make sure that BGP is going to be used for this. Okay, so what I have done is here, show run section EVPN, and I'm going to mention something very important here. Let me do this, show run BGP as well. Okay, so see here, what I have done is I have used route targets. you know that route targets are extended communities. And if you do not enable extended communities under the relevant address family, you're going to be in trouble, right? So this is one of the parts that, like I said, I have made deliberately a mistake in here, and I'm just going to see the effect of that. Okay, no problem. So let's just go do the same thing on the other side. So what I'm going to do is to go to this EVPN. I'm just going to copy this and paste it to the other side because I have the same thing exactly here. So section EVPN is going to be added. That's one thing. And also under NVE interface, I'm just going to make sure that this host reachability has been selected for BGP. So interface NVE1, I'm going to do this. Okay, so most of the configuration has been done. Some mistakes are there. Let's see the effect of that. Okay, the first thing that I'm going to see is show MAC address table. Okay, everything seems exactly the same as it used to be, but except the fact that I have aged out some of these. Let's try to reach from switch 5 to switch 7. I'm just going to go to switch 5, and I'm going to say ping 192.168.10.7. And let's see if this is possible. Okay, the reachability is not there. So there's a problem in here. Let me see. If I go to L1 and try to see the MAC address table. MAC address table. So I have this. I have no idea where the destination is. The same thing is going to happen in here. I have no idea where the source is. So we don't have anything in here. Why? Because first of all, we have selected this in here, which means that now data plane is going to be involved in learning. And I'm trying to reach the information for the source or for the destination from BGP. And BGP doesn't have anything. How do I know that BGP doesn't have anything? So let's see. If I say show BGP, address family, sub-address family, and hit enter, so you can see that I know about me. I don't know about the destination. What is the problem? Let's go to switches up here, spines. On S1, I'm going to say show BGP, address family, sub-address family. So I don't have anything. Let's go to S2. I don't have anything. So one of the problem is I have not redistributed anything, I have not advertised anything to spines in here. So what am I going to do? In your network, you need to have at least one route reflector so that, first of all, you receive the prefixes from leaves and then advertise it to other leaves. So you know that there is a rule about route reflector. Route reflectors receive the prefixes from clients and advertise them to other clients. Normally, BGP speakers do not advertise anything that they have received from an IBGP neighbor to another IBGP neighbor, but route reflector is going to do this for us. In this case, S1 and S2 are going to be route reflectors for us. So in here, what I'm going to do is to say neighbor 10, 10, 10, 3. I'm just going to say route under address family, actually. So route address family L2 VPN EVPN route reflector client. And for the other one is going to be the same thing, route reflector client. So far, show run BGP. I can copy this and paste it to the other side. So you can see that route reflector client has been added to here. So I just paste it in here. Okay, so the other thing. So you can see that there is a change in the neighborship. The other thing, let me see. Show BGP, L2 VPN, EVPN. So EVPN summary. Okay, we have the adjacencies here. So what about the prefixes? Have I received it or not? I don't see any prefixes in here. What about the other side? On S2. Do I see any prefixes? No. You would say, okay, I am neighbor with here, Even if I go with the normal rules, I should be receiving the prefixes from an IBGP neighbor. So why am I not? As a matter of fact, the problem is all the things that you are sending here contain a community value, and that's the route target. And when you don't have this community value, then you cannot really send it to the other side. So I need to make sure that my communities are sent to the other side. So this is the second mistake, and we are trying to fix it in here. Okay, let's go with this. So if I just go under this address family in here, I'm going to say send community, and I'm going to say both actually. Extended is important for us, but let's say both, okay? So for this one, and for address family L2VPN, EVPN, I'm going to say send community both. Okay, same thing should be done on all of these here. So show run BGP. Once again, I'm just going to copy and paste everything to S1 because these two are identical. So that's it. On L1 and L2, of course, the same thing is going to happen. So I'm just going to say show run BGP. Okay, let's go through this. Address family L2 VPN EVPN, and I'm going to send community both. Same thing for the other neighbor. Okay, remote AS, address family L2 VPN NVPN, and send community both. Show run BGP. Same thing could be copied to the other side. So I'm just going to copy this to L2, and everything should be all right. Okay, so here, something that is important is this. On spines, we see leaves as route reflector clients. This is important for us. And also, communities are sent, which is important for us. Correct address family has been configured, which is important for us. Great. Now that we have done this, I'm just going to see this. Show BGP, L2 VPN, EVPN. Okay, for now, I don't have anything, but let's see if I have the neighbors correctly configured. This one is okay. On S1, show BGP, L2 VPN, EVPN. Okay, so I have some entries in here, interestingly, from both sides. Very good. And then I'm just going to make sure that EVPN summary, all the neighbors are intact. Great. Let's just go back to S2 and see this. After some time, I should see some of the prefixes in here as well. Let's go to S5 and try to reach to the other side now. I'm just going to hit enter. Reachability is there. So we have just fixed some of the problems. Some of the problems that we might see in here is this. As you can see in the list up here, if VTEPs are not reachable, VTEPs are going to be our leaves. As a matter of fact, here, tunnel endpoints. We are going to create tunnels from here to the other side. So first of all, I need to make sure that leaves are reachable to each other. So VTEPs should be reachable. Loopbacks should be there. The configuration should be there. Specifically, some of the things that are important for us is for each VLAN, you need to configure EVPN with the correct VNI, and you need to make sure that a route target and a route distinguisher has been configured for that. And most likely, it is better to go with auto, and that's going to be much better. And L1, I'm just going to say show BGP, L2 VPN, EVPN. Now I have some information about this. You can see that I have this route distinguisher, which is correctly automatically configured for me. As a matter of fact, this is a type 2 EVPN route. It is 48 bits, and this is just a MAC address. And you can see that it doesn't contain any IP address because this is not type 5 actually. So the advertising VTEP is 1113, which is L1, and some stuff about the rest of the prefixes. And also the other thing which is important for us is to make sure that, like I said, debugging is not a good thing. You should not really go with debug. Capture is better, monitoring is another thing, and going with some commands for verification is going to be important for you. So we have just done this part, and I hope this has been informative for you.